Well, hello there. You clicked on this video because either you wanted to learn more about algebra or review it, or, more likely, you wanted to be put to sleep. Either way, let's just get into this. First of all, in this video, we're going to be covering all these different units of algebra. There may be more considering on where you are, but according to my teacher in my region, this is basically all you have to do. So those number systems, when you identify if a number is real, imaginary, rational, or irrational. Absolute value is a number's distance from zero. So let's say you have the number negative 35. It is 35 units away from zero. And the same goes for 35. Don't worry, we'll cover this in future videos. Simplifying radicals, quite self-explanatory. Combining like terms, look, it's also self-explanatory. Evaluating expressions, would you guess it? Also self-explanatory. Functions, linear equations, systems of equations, solving equations, and partially even solving inequalities. They're all just different parts of equations. There's the Pythagorean theorem, where we also, covered the Pythagorean theorem, and angle relationships, where we learn about all the wonders which transversals can do for us. In the next series of videos, we'll cover these, and then the next after that, we'll cover these, and then these. Yeah. So, for number systems, I'm going to give you an example problem to try and give some more context. Describe and give the value of negative the square root of 100. The answer must include the rationality, and if it is imaginary, state that it is. Also include the actual numerical value in your answer. However, if it is imaginary, because most algebra classes don't actually go that deep into imaginary numbers yet, you would just have to say it's imaginary. You might be wondering what imaginary is. So, yeah. I'm just going to give you the answer choices. So, irrational, it's negative 50. Imaginary, irrational, it's negative 10. Rational, it's negative 10. Now, what exactly is a square root? A lot of you may know, so skip this section if you want. But there will be stuff about imaginary numbers in case you need to know about that. So, yeah, this is the definition for, square roots. Hope you're reading, because I'm not. My voice is tired. So, I don't like this definition personally, and I really did not like it when I was learning. So, I'll just give you some examples. I really should have thought this through because now I have to give these up on the spot. Square root of 4. So, let's start with the square root of 4, right? We have the square root of 4. So, I'm pretty sure you know that the square root of 4 is a perfect square. On those tables you learn 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, all of that. So, what number, what the square root is asking is what number, when you multiply it, gets to that 4? Well, in this case, it's the 2, because 2 times 2 is 4. We can go on with other stuff. There's 16, let's say. 16 is 4 times 4, so the square root of 16 would be whatever you multiply by itself, which would be 4. The problem is, not all of those numbers cleanly multiply there. That's how we get irrational numbers. Let's start with the square root of 8, right? That's gonna be messy because, for really a lot of reasons, but we just need to see that is irrational because there is no whole number which, when squared, gets 8. Later on, we're going to be covering what we do with the square root of 8 and how we fix it up. Generally, though, for this particular unit, you're not going to need more. But what if you take the square root of a negative? Let's think back about what a square root is. So, the square root of x is a number that can be multiplied by itself to get x. If you multiply by a number by itself, can you even get a negative? Think about it. So, what are the ways you can get a negative? A negative times a positive times a negative, but a positive and a negative, they both just give a positive, And because we're multiplying a number by itself, that's just going to give the positive, those two cases, which work. In case you don't quite understand what I'm saying right now, there are a few cases which make a number positive or negative when you multiply it by another of its type. But because we're taking the square of that number, it's gotta be positive. So there is no real square root of negative. Real, that's the key word. You see, mathematicians really, really like the concept of a number which, when squared, would give a negative number. This would help them in a ton of ways. That's not really important right now. But they just decided to make a new number, which, when squared, gives negative something. They used I. I squared is equal to -1. And this was basically revolutionary. I stands for imaginary, and that's where it comes in. So let's look at the actual problem now that we know a little bit more about square roots and imaginary numbers. So, describe and give the value of negative the square root of 100. So we're going to start with the square root of 100. Let's check our table. We know 1 times 1 is 2, 2 times 2 is 4, 3 times 3, all the way up, and we see 10 times 10 is 100. For this reason, we know that the square root of 100 is 10. Now you have -1 times 10. If you're wondering where the -1 came from, it's because of this negative symbol. My teacher has drilled it into my brain that you need to act like there's a 1 there, even if there's not. So that will just give us the rational -10. All of these other things don't work because, 1, the negative is not in here. That's why it's not imaginary. You see, this is just -1 times the square root of 100. It's not the square root of -100. If it's the square root of -100, then we'd have to get I involved, and when I gets involved, we have to be imaginary. And that's not really good. So, it's also not irrational, because this is one of those clean numbers, which goes into a whole number. And, of course, not this one, either. Well, there's another, last type of problem, which we're going to cover. -1 times the square root of 49. 1.979797 and so on. -1 times the square root of 19, and 1/5. Which of these is irrational? So, let's start with -1 times the square root of 49. So, the square root of 49, let's check our list. 6 times 6 is 36, 7 times 7 is 49. Perfect. So the square root of 49 would be 7. -1 times 7? -7. That's not irrational, though, so that doesn't work. Last year, you probably should have known that, 1/9, that's not gonna make some nice decimal. Because of some long division stuff, that's just gonna give you 0.111111 repeating forever. Whenever you see some of these repeating numbers constantly with a pattern clearly in them, you know there's a 1/99 or x over 999, x over 9999. That's basically how it works. So when we see this, we know it must be a fraction. Irrational numbers, they cannot be made as a ratio. A ratio is basically x over y. Can you write, you can write any rational number as x over y, but not irrational numbers. So if we can truly do that to b, then it must be rational, and that means it's not irrational. So b is also not an option. Now let's look at c. -1 times the square root of 19. Square root of 19 is not one of those nice numbers, which is good. We finally found an irrational number, and it's negative the square root of 19, which is irrational. We don't even have to look at 1/5, but it's literally in a ratio. How can it be not how can it be irrational? That doesn't make any sense whatsoever. So, yeah. I just have one last thing, one last problem style to show to you. Now, are the numbers below rational or irrational? Really, really easy. Negative 326 is rational because it can be expressed as a ratio. Negative 326 over 1. And 2.4562 over 1, that won't work. But we can do other stuff. Like, we can have, I'm just looking at my numbers because I need to check my notes. 24,562 over 1,000. That will give you this number. You're wondering why? Just remove that. 24562. 24,562 divided by 1,000. Oh no, my stuff is getting messed up. Now you have to move the decimal spot for the 100 a few times. So the decimal doesn't go here. It jumps again. It jumps again. Jumps again. And finally, it jumps one last time. Wait, did I ignore that? Yeah. So you can express that as a ratio, so they're both rational. Before I leave, I would like to show you a joke of mine, one of my favorites from a long time ago. Yeah. Also, consider subscribing if you want to go to sleep faster and with more videos, or you just want to prepare for your finals. Like me, I'm dying. Please